Our first example of solving a rational equation is number 6 out of the textbook. We have the rational expression n minus 7 over 8 equals 5n over 3 minus 7 over 12. So our first step is to figure out what is the least common denominator of all three of these rational expressions. The least common denominator in this case is going to be 24. So what we're going to end up doing is we're going to multiply each part or each side of this equation by 24. And what's going to happen is this is going to end up canceling out all of the denominators, so we're left with just the numerators, which then we later will have to simplify. So 24 and 8, that's going to cancel, and you'll be left with just 3 times n minus 7 equals, and then over here, the 3 and 24, you're going to be left with 8, so you'll have 8 times 5n. And then the 12 and 24, if you cross cancel there, you're going to be left with 2. So we'd have minus 2 and then the 7. And then we can go through and simplify this. So over here, we're going to have to use the distributive property. So we have 3n minus 21 equals, and then over on the right-hand side, we'd have 40n minus 14. And now this looks just like a multi-step equation with variables on both sides. So we would start off by subtracting 3n from both sides. Then we would be left with negative 21 equals 37n minus 14. Then we would add 14 to both sides. And then we would be left with negative 7 equals 37n. And then we have one more step, which is to divide both sides by 37. And so our answer for this rational equation is going to be negative 7/37 equals n. For number 8 now, this one's a little bit more complicated because we have some variables on the bottom of each of our rational expressions. So first we have to figure out what is the least common denominator between m, 10, 2m, and 4. So if we take a look at each of these factors, m is its own factor. 10 breaks down into 2 and 5. 2m has factors of 2 and m, and 4 breaks down into 2 and 2. So the least common denominator, again, you're going to look at each of the individual factors, each of the individual unique factors, and choose the ones that occur the most. So the m only occurs once in each of these cases, so it doesn't matter which one we use. 5, again, only occurs once, but the 2's, we're actually going to use the 2 times 2 here, the 2 squared, and use that in our least common denominator calculation. So least common denominator is going to equal 2 times 2 times 5 times m, which is 20m. So that's what we're going to multiplying each side of this equation by in order to eliminate the denominators and be left with what's going to look like, again, an equation with variables on both sides. So rewriting this equation, we have 5 over m minus 3 over 10 equals 3 over 2m minus 9 over 4. Again, we're going to multiply each side by our least common denominator. And then we're going to start doing some canceling. So over on this side, the m's are going to cancel here. So the 20m and this 5 over m, the m's cancel out, so you'll be left with just 20 times 5. And then over in this next one, the 20 and the 10, 10 is going to be divided by 10 and gets 1. 20 divided by 10 gives you 2. So really we're just going to be doing 2m times 3 equals, and then over on the right-hand side, the 2m and the 20m, that's going to end up canceling out the m's, and then you're left with just 10. So really you're going to be doing 10 times 3, and then over with the 9/4 and the 20m, after doing all that multiplication and the cross-canceling there, you'd be left with 5m, which you're going to be multiplying by 9. And now simplifying this further, we'd have 100 minus 6m equals 30 minus 45m. And as you can see, now we have this equation with variables on both sides. So starting off, we're going to add 45m to both sides. That's actually one of four ways that you could start this equation, but this is going to be the one that is going to be the most straightforward, where you don't end up with any negative coefficients. So we got 100 plus 39m equals 30. Then we'll subtract 100 from both sides. So we'll have 39m equals negative 70. And then the last step is to divide by 39. And so we end up with m equals, and then negative 70 over 39. Now in this case, since we have variables on the bottom of our initial equation, we do want to make sure that our solution makes sense and that it's actually valid. And back in one of the previous lessons, we talked about what is a restricted value for these rational expressions. And in this case, restricted values for m would be m equals 0, because that's going to make the denominator equal to 0. And if we have a denominator of 0, it makes it undefined, the rational expression. So we don't want that to happen. Since we didn't get an answer of 0, this is okay. The solution checks out. So always make sure you take the time to double check to make sure your solution is not a restricted value. If you end up with a restricted value, then that's not going to be a possible solution.